This is a video on the quadratics module. In this video we'll be looking at section Quad C. In this section we're looking at special cases of quadratics. Now when the bracketed factors for a quadratic expansion are of a certain type, special expansion rules may be applied. Appendix B in your textbook illustrates representations of the following special cases, quadratic expansions. When the two factors are of the form x plus a and x minus a, where a is a constant, the result of the expansion is the difference of squares. So, for example, here is my x plus a, x minus a, expanding it like we did in the previous video. X times x is x squared, x times negative a is negative ax, a times x is plus ax, a times negative a is minus a squared. And what you'll notice is that we have a negative ax and a plus ax, so they cancel and just leave x squared minus a squared. Okay, so the difference of two squares formula is if we have x plus a, x minus a, it's simply x squared minus a squared. Now it's not important which bracket contains the plus or the minus, the result is still the same. Okay, so be careful when you're looking at expanding for difference of squares. So let's look at some examples. Here I have expanded the following using the difference of squares rule. So I have an x plus 2 and x minus 2, so it's definitely a difference of squares. My first term is x and I need to square it. My second term is 2, I need to square it, so I'm left with x squared minus 4. Okay. My next one, x minus 7, x plus 7. I have the same brackets with a difference of a minus and a plus. So my first term is x, 4 squared. My second term is 7, 7 squared is 49. Okay. Next one, 2a minus 4, 2a plus 4. Exactly the same brackets except for the minus and the plus. So my first term is 2a and I need to square it. My second term is 4, 4 squared is 16. Now 2a squared is 4a squared, and that's minus 16. Next, 3a plus b, 3a minus 2b, 3a plus 2b, 3a minus 2b, exactly the same brackets except for the plus and minus. So my first term, all squared, minus my second term, all squared. So 3 squared is 9, so I've got 9a squared, minus 2 squared is 4b squared. Now let's look at the square of a sum and the square of a difference. When the factors are the same, the quadratic expansions result in the following. So if I'm looking at a square of a sum, I have x plus a all squared. Now if I wrote that out in full, it's x plus a, x plus a. Okay? Expanding that out, x times x is x squared, x times a is plus ax, a times x is plus ax, a times a is plus a squared. Collect like terms in the middle here. So I have x squared plus 2ax plus a squared. So my square of a sum can be simplified as, if I have x plus a all squared, it's simply my first term squared plus 2 lots of my terms multiplied by each other plus my last term squared. Now if I'm looking at square of a difference, that means I've got x minus a all squared. So let's do it the long way. So I've got x minus a, expanding it out, x times x, x squared, x times negative a, it's negative ax, negative a times x, it's negative ax, negative a times negative a is plus a squared. Collect the like terms in the middle. So I have x squared minus 2ax plus a squared. So my rule here is that x minus a all squared is simply the first term squared minus 2 lots of the terms multiplied by each other plus the last term squared. Now again, only the results of the expansions are used when expanding quadratics of these forms. So let's look at an example. to start with, we'll look at the square of a sum, and I've put that, at the top to refer to. Okay, so if I've got x plus 2 all squared, first term all squared, plus 2 lots of the middle terms multiplied, plus 2 lots of the two terms multiplied by each other, so times x times 2, then plus the last term squared. So I have x squared, 2 times x times 2 is plus 4x plus 4. Okay, next one, first term squared plus 2 lots of, multiplying each of the terms, then plus the last term squared. So it's x squared, 2 times 7 is plus 14x, plus 7 sevens are 49. You don't need to write out this middle step, you can do that bit in your head. So here, first term, all squared, plus 2 lots of, let's multiply the terms, plus the last term squared. So I have 4a squared plus 2 times 2 is 4, 4 times 4 is 16, a plus 16. Okay, last one, first term, all squared, plus 2 lots of, multiplying the terms, plus the last term, all squared. So that's 9a squared, 2 times 3 is 6, 6 times 2 is 12, last term all squared is 4b squared. Okay, so it's just a little bit of a shortcut. Now let's look at some examples with the square of a difference. Okay, the only difference is we're going to have minus in our second term. So here, first term all squared, now minus 2 lots, multiplying the middle term. And then my last term all squared. Okay, so I have x squared, negative 2 times 2 is negative 4x, then plus 4. Okay, next one, first term all squared, minus 2 lots of multiplying my other two terms, then plus my last term squared. So x squared minus 2 times 7 is 14x, plus 7 sevens are 49. Okay, next, first term all squared, minus 2 lots, multiplying the two terms, plus the last term all squared. So I have 4a squared, minus 2 2's are 4, 4 4's are 16, plus 16. Last one, 3a all squared, minus 2 lots, multiplying my other terms, plus my last term all squared. So that's 9a squared, minus 2 3's are 6, 6 2's are 12, and then plus 2 2's are 4, 4b squared. Okay. What now? Well, you need to practice, and 2 exercises that you can now complete are quad C1 and quad C2. Please remember to ask for help if you need it.